Hello everybody, hope all of you are well, and today I will continue your organic chemistry part, that is nomenclature. So first today we will discuss the nomenclature of alkyne. First we have to select the longest continuous carbon chain, okay, as parent chain, on which the various alkyl groups are considered as substituents. So here if we take this example, so we have to give the minimum position. Here we are getting the substituent at 1, 2, 3, 4, 5. From this side we are getting 1, 2, 3, 4. So from this side we will give the name 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will be the longest carbon chain. In this way we have to select the longest carbon chain. Then numbering is done from the end, that is nearest to the substituent. Already we have done. Next one is the first point of difference rule. Suppose in this example, here we are getting two substituents at the position 1, 2, 3. But here we are getting the single substituent, okay, one methyl group at the 2 position. But as here we are getting this methyl group at the nearest, okay, at the 2 position. But here from this side we give the name, we are getting it at 3 position. So we have to consider that first point of difference rule. So choose the longest number, okay, longest number chain we have to choose, as well as the first point of difference is here 2. So if we give the name, so we have to write 2,5,5 trimethyl heptane. In this way we will give the name of this compound. Hope you can understand. Now in the next example, this is the next example. Here you see the next example. So here at the 2 position, if we take this chain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this will be the longest. And here if we start from 1, 2, 3, 4, 5, actually the summation rule, that the lowest sum rule, it was in the earlier time. But now we have to give the first point of difference. As we are getting the 2 position 1 substituent, here if we start from naming here, okay, from this side, then we get the 3 position. So here earliest lowest sum rule was used, but now we have to use the first point of difference rule, even if it violates the lowest sum rule. Because if we give this here 1, 2, 3, 3 plus 4 plus 5, okay, and then if we add this thing, okay, if the total value will be less compared to this one, okay, we will not consider it here. So we have to give the first difference. Here we are getting the substituent at the 2 positions. If two different alkyl groups, okay, are at the same position. Suppose here in this example, here at 2 position 1 alkyl group is here, and here also 3 position 1 alkyl group is there, methyl, and here from this side 3 position also 1 alkyl group is there. Then what to give the preference? So here we have to give the alphabetical preference. So from here we numbering from this side 1, 2, 3, 4, 5, 6, 7. Methyl and ethyl. E is alphabetical preference compared to the M. So we are giving that 3 ethyl, 5 methyl heptane. That you have to give in this way. Next one is the numerical premise. If a substituent occurs more than once, then the prefix di, tri, tetra, penta we have to use. Suppose if there is 2 methyl, then we have to use dimethyl. Okay. If we consider this example, then you can understand 1, 2, 3, 4, 5. So at 2 position 2 methyl group is there, 4 position 2 methyl group is there. So definitely we will give the name 2, 2, 4, 4 tetramethyl pentane. In this way we have to give the name. And here alphabetical arrangement we have to give for the prefix also. Suppose in this case, in the next case, here methyl is there, ethyl is there. So if we write 3 methyl, 4 ethyl, it will be incorrect. Okay, so we have to give the alphabetical preference for substituent also. It is the 4 ethyl, 3 methyl heptane. In this way we have to give the name. Next, for the complex type of alkyl group, suppose this is not the normal type of alkyl group. So in case of complex type of alkyl group, there also we have to count this chain also. So it is the longest chain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here you have to give 1 dot, 2 dot, 1 dot prime or 2 dot prime, or you can write 1 dot. Then first we will write 2 methyl. Here is 2 methyl. Then 3 1 1 dot dimethyl ethyl. This is the dimethyl and this one is the ethyl, and total 10 carbon is there. That is why we are writing that decade. Now, one word name, that also we have to keep in our mind. Okay, the name of the compound is written as one word numbers. Okay, one word name, and numbers are separated by the names of the substituents by hyphens. So when we write the IPC name, we should not give any space. That you have to keep in mind. But when some complex substituent is present, that more than once time, then what this is complex substituent. Okay, so here also I am giving the example of complex substituent. If the complex substituent is there, then we have to give the prefix such as bis, tris, tetrakis, pentakis, etc. So here I have already given one example. So here if we start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this will be 5, 5, and this is bis. And this one we can write 1, 2, 3. That means 1, 1 dimethyl propyl, 2 methyl decane. In this way we have to give the name. Next we will discuss the IPAC name of the alkenes. So first one alkene is given, but if we give the longest carbon, we will select the longest carbon just in this way 1, 2, 3, 4, 5, 6, 7. Then it will be the wrong. Okay, so here the longest continuous carbon chain containing the carbon-carbon double bond is selected as the parent hydrocarbon. So we have to include this double bond. From here we will give the numbering. We have to give the minimum position, that 1, 2, 3, 4, 5. In this way we have to give the name. And next this one, this example, if we consider that 1, 2, 3, 4. So here we are giving this double bond minimum number is carbon. Okay, and its name will be 3,3-dimethyl-butane. And in this case, that is 1, 2, 3, 4. That is 3-methyl-butane. That will be the name of this compound. We know that we have already discussed, in case of double bond we have to add suffix "-ine", and in case of triple bond we have to add suffix "-ine". Suppose if there is two type of bonds, that means double bond is there as well as triple bond is there. Then we have to write pent-3n-1-ine. That we have to write here ene in. That E is dropped. Okay, that you have to remember. Okay. Next. Suppose in this compound two functional group is there, double bond is there, triple bond is there. But here if we give this is the terminal end, okay, this is also the terminal end. So then which one I give preference, double bond or triple bond? So here we have to give the alphabetical preference. In case of triple bond it will be "-ine, in case of double bond it will be "-ine". So we have to write but-1n-3-ine. So here also E is dropped. Okay, that you have to remember. Next, if there is two double bond in a compound, buta-1,3-diene. Okay, if there is two triple bond in this compound, say 1, 2, 3, 4, 5. So penta-1,4-diene. Okay. Next, if we discuss the another type of compound, that is the cyclopropane type of compound. That means alicyclic compound. If we discuss the alicyclic compound, suppose if we write this one will be the structure of cyclopropane, and if we write this one is methyl cyclopropane. Here we are not writing the position because all position of the cyclopropane is equivalent. But here if we write this one will be 1,1 dimethyl cyclopropane. But if we write this one is 1,2 dimethyl cyclopropane. Next one, this one is called cyclobutane. If there is 5-member ring, it will be cyclopentane. If there is 6-member ring, then it is cyclohexane. But in case of cyclohexane, if there is one double bond, then it is called cyclohexene. Okay, here you need not to mention the position of the double bond. But if there is some substituent, definitely you have to mention the position. Suppose in this compound there is one OH group. Okay, definitely we have to give the functional group minimum number. Okay, so we will give it 1, 2, 3, 4, 5, 6. Okay, so what will be the name of this compound here? This one is cyclohex 3 in 1 all. Cyclohex 3 in 1 all. Cyclohex 3 in, okay, 1 all. In this way we have to give the name. Now we will discuss the IPSC names for complex type of compound. Complex type of compound means if there is two functional groups, same type of function group, what will give the name? So in this case you have to write ethane dioic acid. Ethane dioic acid. Here you need not to tell that ethane 1 to dioic acid because only one structure is possible. It is not required. But if the compound contains tricarboxylic acid, 3 carboxylic acid group, then in this case we cannot take the all carboxylic acid in the same chain. That is why we have to name the main chain as propane. So we have to give the name propane 1, 2, 3. Propane 1, 2, 3 dicarboxylic acid. Propane 1, 2, 3 dicarboxylic acid. Okay. So in this way we have to write the name of the complex type of compounds. Hope you can understand. This one is CHO. Next, suppose in a compound two functional group is present or 3 or more functional group is present, then one will be the principal functional group. And the principal functional group reference already I have given, already I have discussed. Suppose in this compound there is carboxylic acid group and ester group. Definitely carboxylic acid is the principal functional group. So what will be the name of this compound? It will be 3-ethoxy carbamoyl. This is the prefix. Okay, due to enoic acid because 4 carbon is present here. 1, 2, 3, 4. Another type of compound I am showing this here in this compound, 1 carboxylic acid group and 1 aldehyde group. Both are present. So here 1, 2, 3, 4, 5, 6. So here when aldehyde is prefix, we are writing as a prefix, then we have to use formyl. So it will be 3-formyl hexanoic acid. Okay, now in this compound, amide group is present, cyanide is present, OH is present. Okay, so which one will be the principal function group? Amide. Okay, so we know that main name is the alkanamide. So it will be 3-cyano-5-hydroxy. Okay, 3-cyano-5-hydroxy hexanamide. Hexanamide you have to write. Next we will discuss the functional group. Next we will discuss the nomenclature of the aromatic compounds. Okay. First we can write the aromatic compound. All of you know this is the benzene. This is IPSC accepted name. Then we can write, if we add one CH3 group, then it is called toluene. Okay. If 2 methyl group is present at 1, 2 position, so this 1, 2 position isomers, they are called orthoisomer. This one is called orthogylene. And another name is there, that is called 1, 2 dimethyl benzene. Both are IPSC accepted. Okay. And here, if we write this one, if there is 1, 3 position of the benzene, if there is methyl group, then it is called metagylene. If the 2 methyl group is at the 1, 4 position, then it is called paragylene. In this way, we have to write the isomers of type of benzene. Now, if the 2 benzene rings are huge, then it is called naphthalene. If there is 3 benzene rings attached or fused with each other in a linear way, then This compound is called anthracene. If the benzene rings are fused in this way, then this one is called phenanthrene. So in this way you have to remember the aromatic system also. Okay, these are very important. If benzene ring attached with one chlorine, then it is called chlorobenzene. If benzene ring attached with bromo, then it is called bromobenzene. If benzene ring attached with one OH group, then it is called phenol. If benzene ring attached with one NH2 group, then it is called aniline. If there is one COOH group attached to the benzene ring, then it is called benzoic acid. All lists are given in your book. You have to read thoroughly. If the one aldehyde group is present in benzene ring, then it is called benzaldehyde. If one nitro group is present in benzene ring, then it is called nitrobenzene. Okay. Next we will discuss some nitro compounds of the aromatic system. Suppose this one. So this one is called trinitrobenzene. Okay, this is an explosive. Polynitro compounds are all explosives. Okay, if we give here one CH3 group, and these are the three nitro groups. This one is 1, 2, 3, 4, 5, 6. That is 2, 4, 6 dinitrotoluene. This compound is also called TNT. Short name is TNT. 2, 4, 6 dinitrotoluene. Okay. If there is 2, 4, 6 dinitrophenol, then it is called picric acid. 2, 4, 6 dinitrophenol. Its common name is picric acid. IUPAC name you can write that 2, 4, 6 dinitrophenol. Okay. So in this way you have to practice the nomenclature of aromatic system. Suppose if in a aromatic system there are more than one functional group. Suppose one CH3 group is there, one Br group is there, and one chlorine group is there. So how to give the name here? So here the functional groups are halide, chlorine and bromine. So as we have to give which one? So minimum number we have to give. So here we can give that this one is 1, this one is 2, this one is 3, this one is 4. In this way we can give the name. That is 2 bromo, 1 chloro, 4 methyl benzene. Okay. Next in your syllabus there is some bicyclo type of compound and spiro type of compounds. Okay, that also you have to know. I am giving just 1-2 examples from this thing. Suppose this type of bicyclo compound is there. So how to give the name of this compound? So here you have to write bicyclo 2,2,0 and total number of carbon atom you have to count in this way 1, 2, 3, 4, 5, 6. Excellent. Hope you can understand. Okay, this one, these two is these 2 carbon, and here at the junction 2 carbon is there, and in the middle there is no carbon atom, so that is why 0. Suppose if we write this one will be bicyclo 4, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, decane. Bicyclo 440 decane. So in this way you have to give the name. And in case of spiro type of compound, so this is spiro type of compound. So how to give the naming here? 1, 2, 3, 4, 5. So what will be the name of this compound? This will be spiro 2,2-pentane. Spiro 2,2 pentane. So here this side 2 carbon is there, this side 2 carbon is there. This is the spiro. Okay, this is this cross. So this side 2 carbon, this side 2 carbon, that is spiro 2,2-pentane. Okay. Now if we write this one, definitely in this case it will be spiro 4,4. This side 4, this side 4 carbon, 4,4. Okay, total number of carbon we have to count in this way 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 or 4, 4 no name. Hope you can understand. Many examples are given already in your book. Okay, that you have to practice. So in this way, I have completed your nomenclature. Many nomenclatures are there that you have to practice from your book. If you practice, then it will be easier for you. Many rules are there that also you have to read. Okay. So actually, different types of compounds and or special types of compounds, different types of nomenclatures are there. Okay, and we have already we have discussed what is in your syllabus. So next one we'll discuss that isomers. You know that isomers are same molecular formula but different structures. Okay, and this phenomenon is called isomerism. When the same molecular formula represents two or more compounds which differ in the arrangement of atoms between the molecules, then such compounds are called structural isomers. Actually, isomers can be separated into two ways. One is structural isomer, another is stereoisomer. Stereoisomer may be two types. One is geometrical, another is optical. And structural isomer, you know from your lower class, there is chain isomer, functional isomer, positional isomer, metamer isomer, ring chain isomer, and tautomer isomer. Okay, and today up to this next day we'll discuss more about this isomer. Okay, so today up to this, thank you.